Shirakawa, please.
Thank you, Chairperson. And I'm talking about today's anti-inflammatory effect of the dietary ingredient, especially and engagement of tryptophan and the tryptophan metabolite via aryl hydrocarbon receptor. So before talking into my talk, so I just a little bit touched about the national situation of the Japan. So Nancy already told in the United States situation, but here is a growing national medical expense in Japan. So for more than 60 years. So our national medical expense is actually growing year on year constantly. And maybe this is maybe depend on the expansion of the life average of lifespan, and also increasing the population of the over the 65 years old persons. And 2014 and national expense is now is at 40 trillion yen and almost $360, $3 billion, and also 300 euro, almost billion euro also. This value is actually too much excessive burden to the total budget in Japan and also other countries. So here is a leading disease in over the 65 years old in elder person in Japan. So cardiovascular disease and cancer and musculoskeletal disorder, including osteoporosis and also sarcopenia. These are categorized in the lifestyle-related disease. So chronic and low-grade inflammation is the pathogenesis and the background of the onset and the progression of the lifestyle-related disease. So, and we have to suppress the total medical expense, and this is actually a critical issue for the social issue should be resolved. So dietary intervention system. Dietary intervention is one of the way to disrupt this issue, I believe. So we know the many types of the anti-inflammatory food ingredient, like here. So omega-3 fatty acid, DHA, EPA, and amino acid, also protein, and mineral, zinc, magnesium, and vitamin also. Some of the vitamin has an anti-inflammatory effect. And these are actually, and we can easily available from the market, like here as a dietary supplement as a nutraceutical. But we don't know whether these supplement and nutraceutical is actually effect to the human or not. So my CFAI's laboratory is actually one of the my CFAI's laboratory is one of the purposes is the evaluation of this function in the finally humans. But today my topic is inflammatory one ingredient. Now today I pick up the tryptophan. Tryptophan is actually an essential amino acid, you know, and for protein synthesis. But this tryptophan can metabolize the several types of the metabolite to the several kinds of the indoor chemicals. And tryptophan metabolite to the serotonin endogenously, and also niacin by a quinoline pathway. This is an endogenous pathway. And also in intestinal flora, by intestinal flora, tryptophan can convert to the indole and the tryptamine and the indole acetic acid, several things. This is a very, very limited information. There are a huge amount of indole chemicals and metabolites from the tryptophan in the intestine by intestinal microflora. So this red asterisk one is actually and works as a aryl hydrocarbon receptors ligand. What is aryl hydrocarbon receptor? So aryl hydrocarbon receptor, HL, is the one of the transcription receptor-dependent transcription factor regulates the several types of the gene expression. So HL is the firstly identifies the sensor of the environmental contaminant, dioxin. And HL bind to the dioxin in the cytoplasm and move to the nucleus and complex with the heterodimer partner and also bind to the xenobiotics responsible element and simulates the several transcription of the gene, including some kind of the drug metabolic gene. And recently, many persons focused on some kind of the immune regulation gene. So in this time is how I evaluated the tryptophan anti-inflammatory effect. And I use DSS, dextran sodium sulfate induced colitis model. And after ingestion of the DSS, and DSS actually injures epithelial cell layer of the large intestine, lower intestine, and enhance the penetrate to the DSS itself, and also enhance the penetrate its present microbacteria easily. And inflammation is actually occurring, and finally occurring the bleeding of the, and also diarrhea occurring. So here is the experimental design of this experiment. So I use female C57 and wild type and HR knockout mice. And these mice are fed with two types of the diet. One diet is AIN93M diet. This is a very, very standard diet for the rodent. And also other types of the diet is this standard diet supplemented with 0.5% tryptophan. So for the 3 days maintenance, after that drinking water changed to the DSS containing water and induced colitis for the 8 days. And here is a body weight change and disease activity index during the 8 days of the DSS treatment. Body weight is actually decreased at all group except one group. That is a wild type tryptophan supplemented group. And here is a DSS disease index activity. And this is evaluated by the diarrhea and also bloody stool. So all of the group is and disease index activity is increased, but tryptophan and the wild type group is almost stabilized. And also as a inflammation marker, one that disease colitis marker is DSS treatment is occurring in the shorten of the large intestine, like this one. But wild type tryptophan group is actually keeps their length. And also spleen length is actually enlarged by DSS treatment. But tryptophan wild type group is actually normal. And here is a histological analysis in the large intestine. And you can see the breakdown of the epithelial cell and the infiltration of the monocytes in this region. But wild type tryptophan group looks normal. And as a inflammation marker and mural peroxidase activity in the large intestine also, and that oxidative stress marker in the TBARS also decreased in the only wild type tryptophan treatment group. And finally, we try to measure pro-inflammatory cytokine IL-6 and TNF alpha and their expression in the intestine. Every item is actually tryptophan wild type group is actually significantly reduced. So this means tryptophan diet actually reduced DSS colitis inflammation, colitis. And this is actually dependent HL, aryl hydrocarbon receptor. So, but the tryptophan itself is not activates HR itself. So we try to check the metabolite of the tryptophan. So in this time, we only checked one of the tryptophan metabolite, tryptamine. So tryptamine level is this is a faces tryptamine level before DSS treatment. 3 days feeding of the tryptophan diet. And also here is actually DSS after DSS treatment, feces and serum and chronic tryptamine is actually elevated, only detected in the tryptophan diet group. So this means DSS-induced colitis maybe suppress this tryptophan metabolite through AHR activation. And also, HR is involved in some kind of the regulation T cell differentiation, regulatory T cell and Th17 also. So we checked intestinal, large intestinal, these IL-21 and IL-17 messenger RNA level. Actually, anti-inflammatory cytokines, IL-22 level is actually upregulated in only the tryptophan wild type group. And oppositely, IL-17, this is the proinflammatory cytokines, is IL-17 level is actually downregulated in the wild type tryptophan group. So this means that this is a first pass conclusion, and the dietary tryptophan effectively prevents the DSS-induced colitis symptom and the severity. And the dietary tryptophan reduces the inflammation marker and the pro-inflammatory cytokines and regulates the mucosal immunity system through the HR. And also dietary tryptophan increases the microbiome-mediated tryptamine. Now we only check the tryptamine, but I believe that several types of the indoor chemicals maybe function as the HR ligand, maybe also increasing the maybe these upregulation of the indoor chemical maybe stimulates the HR and maybe containing the mucosal immunity in this system. So I moved to another story. Previously, we checked low-level dioxin-inducible gene using some kind of microarray analysis. So in that time, we found one of the stress-responsive protein named methylcyanine. This protein is actually conjugated to zinc and other element, and has a works as a biological protection against toxics of metal and also oxidative stress. So here is the data. So mouse ortholog of the methylcyananes, MT1 and MT2 is actually elevated in the dioxin treatment in the rat liver. In this case, it's a mouse liver. Sorry. But on the other hand, if we use the HR knockout mice, and this upregulation is almost abolished. So this means dioxin treatment maybe induce the methylcyanine gene by HR. But then we confirm this thing in the cell-based experiment. And hepatocarcinoma, hepatitis cell treated with dioxin, and also one of the typical ligand for the HR, 3MC treatment, actually enhance the humans' methylcyanine gene expression, dose-dependent. And also, when we use an MT2A promoters luciferase construct, and dioxin, HR ligand also HR transfection is actually enhanced the luciferase activity. This means methylcyanine gene is actually regulated by HR. So when we look at the promoter region of the methylcyanine gene in the human, but we cannot see any xenobiotics responsive element within the. This is actually very, very small promoter, but there is no XRE in this region. And also, the mouse methylcyanine gene also does not have a typical XRE. So I presume that maybe dioxin is actually stimulate this gene's expression via HR, but maybe not different manner. So HR is actually bind to the XRE and stimulates some kind of gene expression. But ligand activated HR also interacted with other transcription factor like NF-kappa B and estrogen receptor, and to function of the inflammatory regulation and also reproduction system. So we presume that glucocorticoid regulatory region in the MT methylcyanine promoter may be one of the important elements for dioxin-induced MT2A expression. So we presume this kind of the system, GR, glucocorticoid receptors, and HRs maybe interacted with each other and regulated methylcyanine genes. So, when we treated the cell with HR agonist 3-MC and also a glucocorticoid agonist dexamethasone, and human methylcyanine genes actually upregulated synergistically, dose-dependent manners. And also, to confirm the contribution of the both receptors and HR and GR siRNA transfected to the cell and created a knockdown condition. So after transfection of the both siRNA, and these ligand stimulated mRNA expression is actually downregulated. So this means that this MTA mRNA's upregulation is through GR and HR both. And also, to evaluate the contribution of the GRE in the presence of the MT promoter. So we created the mutant promoter of the GRE, and created the luciferase construct. Actually, the GRE mutant is abolish the MCs and the dexamethasones and upregulation. And also, we use three triplicated GRE's luciferase construct also. And this construct shows MT and 3-MC and dexamethasone co-treatment is actually synergistically upregulated the luciferase activities. And finally, to confirm the HR and the GR interaction, we perform the chip analysis. And in the presence of the ligand, HR ligand, and HR is actually bind to the typical promoter in the XR in the CYP1A1, and also MT2A the GRE. And also to confirm the complex of each receptors, and using immunoprecipitation assay, and actually, GR and HR is actually interacted with each other, make the complex, not only overexpression state, but also endogenous state. So this is the second part of the summary, and co-treatment of MC and dexamethasone increased the MT to messenger RNA level in the cell-based experiment. Both HR and GR were required synergistically induction of the methylcyanine gene by HR ligand and GR glucocorticoid ligand, receptor ligand. And the reporter gene assay showed HR activated the GR-driven transcription. And the chromatin immunoprecipitation and the co-precipitation assay indicated HR and the GR complex recruited on the GRE on the MT2A promoter and the enhancer transcription of the MT2As. So this is a final slide. And later part is not improved. Tryptophan is not observed, but we imagine that and the tryptophan ingestion and the tryptophan treatment ingestion, these tryptophans are metabolized to some kind of the indoor chemicals, and these indoor chemicals stimulates the HL and stimulates the gene transcription, not only directly and bind to the XRE, but also not independent of the XRE system. And finally, maybe application of the inflammatory gene expression. So this is an acknowledgement of I would like to thank all of the collaborators showing here, especially thanks for the Dr. Jahidar Islam and Dr. Shoko Sato and the great contribution of this study. Thank you for your attention.